All right, hello again, ATM students. This is going to be the lesson on 4-5 group portion. I just wanted to remind you of my video lesson tips one more time. Make sure you're taking good notes just like you would in class. Have all your materials with you, including your calculator. Once again, we will be using our graphing calculator for this lesson. Make sure you pause it when you need to. And any questions that you have, put them in Google Classroom so that I can answer them. So like I said, we're going to be doing the 4-5 group portion for today. Normally you would be doing these questions with your groups in class, but obviously we cannot do that, unfortunately. So what we're going to do is just go through it together as a class, as if it was a class lesson. So we're going to start on page 521 if you want to follow along in the textbook. So today's lesson is all about exponential decay. That's just like the exponential curve that we saw in the 4-5 class portion, except that now it's decay, which means that the function is decreasing as opposed to increasing. So we're starting up high and it's going downward as opposed to going upward. So here they're talking about coffee. Coffee is a popular morning drink because the caffeine it contains acts as a temporary stimulant. Once the caffeine gets into your system, the amount dissipates exponentially, assuming that you don't add more, of course. Answer every question except for 2 and 6 with a full sentence. So they give us this information. I'll keep it handy for us to be able to reference back to so that we can answer those questions. All right, so number 1 says, if you're the coffee drinker represented by the table and the graph, how much caffeine was initially in your system? So I'm going to pull that table and graph back. If we're looking at how much caffeine was initially in your system, we're looking at 0 hours. We can say that's 180. Make sure you include your units, which is milligrams. Okay, if we're looking at the graph, we're looking at 0 hours, following it all the way up, and you can once again see it's 180, and the units are in milligrams. So I'm going to go ahead and add that as an answer, 180 milligrams. Okay. Number 2 requires a lot of work if you're going to do every single row. I am not going to do every single row. I will maybe do just 2 of them to show you that you should get the same answer each time. But just like in the 4-5 class portion, it says to find the relative change in caffeine for each 1 hour period listed in the table. The table here matches the same one in the beginning of the lesson. And then it says round to the nearest full percent. So I added the times 100 here because we do need to make it a percent. So if I'm going to do, let's say, just the first 2 rows, this is the original amount and this is the new amount, right? Because we're starting with 180, that's the original amount, and then we go from 180 to 144. So if I'm going to use my formula here, relative change, new minus original divided by original, I'm going to do 144 minus 180 divided by the original, which is 180. Okay, and I'm going to go ahead and subtract, press enter, and then divide, and I get negative 0.2. Now, if I multiply that times 100 to get it into a percent, that tells me that I'm dealing with 20%, and it is negative because it's decreasing, right? The amount of caffeine is decreasing in your system. It's going down. So my relative change from 0 to 1 hours is negative 20%. Okay. Now from 1 to 2, I would look at these 2 numbers going from 144 to 115.2. Again, the 115.2 is your original amount minus your, the 115.2 is your new amount. The original is 144. And so I'm going to divide by 144. So let's go through that math again. Press enter before dividing, or at least put the numerator in parentheses. And you'll notice I get negative 0.2 again. If I multiply that times 100, that gets me negative 20%. So the amount of caffeine is decreasing by 20% each hour. Now this is where I'm going to say I'm not going to do every single row. If you would like to, feel free. At least do one more row by yourself just to make sure that the math does work. but I can say with confidence that each time you're going to get negative 20%. Okay. So moving on to number 3, I went ahead and filled in the blanks. You can go ahead and copy this sentence as I read it. Complete this important statement about exponential change. A quantity either grows or decays exponentially when the relative change in that quantity is constant. So notice the relative change is the same. That means that it's an exponential function. If the relative change is negative, it's an exponential decay problem. If the relative change is positive, that means it's an exponential growth problem. But if that relative change is the same for each row, then you know you're dealing with an exponential growth or decay problem. Once again, pause the video if you didn't get that full sentence down. All right, moving on. Number 4 says, looking at the graph of the caffeine remaining in your system, describe what exponential decay looks like compared to exponential growth. I went ahead and drew in what exponential decay should look like and what exponential growth should look like. And what the textbook is wanting you to notice here is that exponential decay drops more quickly at first and then levels off. Drops more quickly at first and then levels off. Exponential growth, however, it's the reverse. It starts off slow and then picks up speed. Starts off slow and then picks up speed. Okay. All right, it says, what's the multiplication factor that you'd need to multiply by a previous hour's amount to get to the next hour's amount? Okay, so remember that the caffeine was decreasing by 20%. So if I wanted to figure out how much caffeine was going to be left in my system in the next hour, I have to basically do the opposite of subtracting 20%. In other words, if 10% of something goes away each hour, 90% of it is left, right? So if we are decreasing by 20%, okay, that's the same as the opposite, which is adding 80%, okay? I got that by doing 100 minus 20 to get the 80% that's left over, okay? So my multiplication factor, I never want that to be a percentage, so I have to divide the 80% by 100. And if you divide 80 by 100, you get 0.8. So that's going to be my multiplication factor. Okay, now it says use your answer to question 5 to write a function in the form f of x equals expression, where the expression describes the amount of caffeine left in your system after x hours. Then it says use your answer to question 6 in the class portion if you need some help. So I went ahead and took what we learned in the 4-5 class portion. Remember, we used variables, of course, but I'm using words here. The number that goes in the very front, in front of the parentheses, is always what you're starting with. It's your initial amount, okay? Inside is your multiplication factor, and then it's always raised to the time, right? So if we're using the caffeine information, we're starting with 180 milligrams. That was question number 1, okay? And then we just determined what our multiplication factor is. That's going to be 0.8, okay? And then we don't know the time yet. We're just raising it to any time that we might want to be figuring out. So for now, we're just put that as a variable. Okay. Moving on. Number 7 says use your graphing calculator to verify that the equation you wrote in question 6 gives you the values in the table and the given graph. Describe your results. So the equation that I just came up with, I'm going to go ahead and type that into my y equals. So I've already typed it in. I have y equals 180 and then parentheses 0.8, close your parentheses, to the x power. I also took the liberty of determining a window ahead of time. So if you go to your window button, you can then enter these values in your X-min, your X-max, your scale, your Y-min, your Y-max, and then your scale. So pause the video if you want to adjust your window. And if you go ahead and press graph, we can see that this graph on my calculator does in fact match the graph that they gave me. And then I can go to the table, and I'll have to round to the nearest whole number, but these numbers do match as well. So if I go to 1, I get 144. That's perfect. If I go to 2, I get 115.2. If I go to 3, I get 92. Here's where the rounding comes in. My calculator says 0.16, but on the paper they have 0.2. It's close enough, it's just needing to be rounded. Okay, so we verified that it did work. I'm just gonna put a little check mark here. We don't necessarily have to describe it. You can just double check that everything came out okay. All right, now number 8, it says use the function you wrote to find the amount of caffeine left in your system after 150 minutes. Hopefully you guys know that 150 minutes is just over 2 hours, okay? 2 hours is 120 minutes, but we have to figure out exactly how many hours this is. So I set up our conversion here first. Our equation is in terms of hours, or at least the information that we were given in the beginning, it's all in terms of hours. So I'm going to take 150 minutes and convert it into hours. That means I want to get rid of the minutes. So I'm going to put minutes in the denominator, okay? And hours has to be in the numerator because that's what I'm trying to convert into. Now then I just ask myself how many minutes are in an hour. 60 minutes are in an hour. So the minutes will cancel. And if I divide 150 by 60, that tells me 150 minutes is exactly equivalent to 2.5 hours. Okay. Now it wants me to figure out how much caffeine is left in our system after 2.5 hours. So I'm going to take my equation that we created. We started with 180 milligrams. My multiplication factor was 0.8, and I'm raising it to the 2.5 power. So I have 180 times 0.8 to the 2.5, and I get 103, let's see. They don't say anything about rounding. Let's just do the nearest whole milligram. So 103 I think would be good, milligrams. Okay. Because we did round, I'm going to just change my equal sign to squigglies just to be technical. It's approximately 103 milligrams of caffeine remaining. Okay. All right, we just have a little bit left. Number 9 says use the graph to estimate the amount of time needed for the amount of caffeine to drop to 40 milligrams. Describe how you found your answer. Okay. If we want to know how long it's going to take for the amount of caffeine to be down to 40 milligrams, I have to first find 40 milligrams on the graph, and then I'm going to follow that along. Okay, and it's going to be just about, right, you can tell it's right around 7, okay? In order for it to be exactly 40 milligrams, it's just before 7. You can tell that it's not quite to the line, okay? So using that information, we're going to say it will take a little less than 7 hours to reach 40 milligrams. Now it does say describe how you found your answer, but I just verbally gave you a description. So always be prepared to back up your answer, but to shorten this video, I'm going to just leave it at that. All right, number 10 says either use the table or the trace commands on your calculator to try to come up with a more accurate estimate of the time needed for the caffeine level to reach 40. So we were able to say a little less than 7 hours, but they want me to be more accurate. So if I go to my table or my graph, you know, you don't want to eyeball it. There's this button called the trace button. So I'm going to press that, and you can move the trace cursor using your left and right arrow keys. And so as we go along, my Y value, which is my caffeine milligram amount, it starts to decrease, okay? I want to know when is it going to be close to 40. So I keep tapping, 43, 42, 41, right there. That's what I want, 40.1. That's pretty darn close. If I go further down, I'm closer to 39, so I want to stick to this one. So using the trace button on my calculator, I can say X is about 6.7. So using the X value here, X is 6.7 when Y is equal to 40, okay? So I can say it will reach 40 milligrams at about 6.7 hours. Okay, and that's the last question. So once again, if you have any questions about this lesson, feel free to put them in the Google Classroom comment section and I'll be sure to quickly respond to it. Hope you guys enjoyed watching and I'll see you next time.